Hello. In this video, I'll describe how to run a SvelteKit node on EC2 behind CloudFront. In a previous video I made, I described how to set up SvelteKit with AWS, but that was through a single page application. So this process will utilize server-side rendering, which is what SvelteKit is primarily being developed for. So I'll kind of just walk through the important files and kind of read each block and describe to you, any information that'll help explain what each piece does. So in the README here, and also this will be available on my GitHub. So if you just want to jump into the code, a link will be provided in the description box. So in the README here, so the build section, so you got a few commands here. So this first command is similar to npm install, I believe. The command that populates the node modules folder. So I guess I'll pull up the documentation here. So this is the adapter node documentation. And if you scroll down, there'll be a section that talks about this. Let's see. Well, at least I thought there'd be a section that talks about it. Oh, here we go. So deploying. So it's suggesting that you need to do npm ci and then a prod argument. The only difference I can find is that the node modules folder went from being 160 megabytes to 30 megabytes. And you don't have to, if you had already run npm install, you don't need to delete the folder and then run this again. You can just run it and it seems to kind of delete files for you. And so yeah. So, well, I should kind of explain why you would need to run that. So if you look in this documentation, well, in the same section where this command is referenced, it's saying you need to run the SvelteKit node, you need the package.json file along with the node modules folder and the build folder. So that kind of explains this and the next one, npm run build. That's the kind of normal process to build your application. And here I've set it up, the whole system is set up to where when the EC2 instance first starts up, it'll just download the files it needs from an S3 bucket. And you can set this up different ways. Like you could probably set it up where it maybe downloads the source files from your GitHub repo and then builds it on the instance. You'll have to look into the pros and cons of each. One con of this I've noticed is that, the node modules folder, it has like a lot of files, and S3 charges you like per a certain amount per 1,000 of put requests. So depending on how big this folder is, that could add up over time. So you might want to look into this and just see what solution would be the most cost effective, but for the example of this tutorial, I'm going to do it this way. So yeah, so those are the three things you need: the build folder, the node modules folder, and the package.json. I'm going to skip down so the restart. So the idea here, as I kind of briefly hinted at, whenever you make a change to your website, you're going to run this command and this command, and you're going to copy them over to your S3 bucket, and then all you'll need to do is call a start instance refresh. So, and this is in reference to EC2's auto scaling feature. So basically, this will reset all the instances, and then on startup, this whole process will start again, where a new instance will be created, it'll download the new files, and then you'll be good to go. And the cool thing about this is your whole website won't go down. So the auto scaling feature keeps your existing instances alive and will add the new one and then delete the old one. And those are things you can manage through the configuration settings in the template file, and we'll get to that in a bit. And then last thing down here is the user data log file. So when I was first kind of setting up the startup script, the user data script, as you can imagine, it didn't work on the first try. So this is where you can find the log file of why your instance didn't start up properly, and it'll start up, but why my web server didn't start up properly. So you'll want to either SSH kind of from your desktop, or what I just did was go to the AWS console, and you can connect to your EC2 instance directly through there, and then find this log file through there. So that's this README file. Let's move on to the SvelteKit config file. So this is just a one-line thing, similar to my previous video where we use the static adapter, I believe. Here we're using the adapter node adapter, the node adapter. So we just commented out the auto and inserted the node one. And that's all you have to do here. All right, so the template file. So some of the things you'll see here are similar to my previous video, but I'll try and just give a brief description anyway. So here we have a set of parameters. So is dev. So I use this, in conjunction with, as you can see down here, this condition. Basically, you might have some parameters that will be different if this is a dev environment or production. Similarly, there'll be some resources that you don't even want to make if it's a dev environment. So that's what I use that for. So by default, it's true, and then if you want to set it to false, you have to say so. And then domain name and ACM certificate ARN, these you can leave blank if it's a dev environment, and if it's a prod, you would put your domain name. For me, this is nabware.com, and you need to copy and paste the certificate ARN as well. So that's in the conditions. We kind of went through that. So mappings. This is something new I've learned about. So below, we're going to need these bits of information, and they're region-based bits of information. So with mappings, you can define, let's say, you did want to cover multiple regions, you can set up a little block for each region that you want to deploy to, paste these values in. And this, for example, this AMI is the whatever the latest Amazon Linux 2 version there is. And subnets and VPC, again, I just went to the console and whatever the default ones are, I pasted here so that I can use in the resources below. So the first resource here is the CloudFront distribution. So here you can see I set the website origin and it's pointing to the load balancer, and we'll go over the load balancer in a bit. But because we have an auto scaling group, you'll have multiple EC2 instances, and therefore you need a load balancer to point traffic to each instance. And so here, the load balancer will be listening on HTTP if it's a dev environment and HTTPS if it's a production environment. And that's, for the load balancer, if you're listening on HTTPS, it requires you provide the ACM certificate. And so in the dev environment, we don't need to be setting up custom domain names for this since we're just testing. So that's why this is set up this way. So the default cache behavior, so I've set up a cache policy ID here because the reason I'm not using the default cache policy that they have is because for dev environments, actually, let's just scroll down to the cache policy right now. For the dev environment, I don't want any caching because, if I'm constantly testing things, I need the latest data. And that's the reasoning for that. And this is something new, origin request policy. So I was running into an issue where when I was in a production environment, I was getting a 502 error from CloudFront. And I found, I don't know where it is now, but I did some searching and somebody suggested that when you're going across HTTPS, there are some headers that need to be passed to the origin in order for CloudFront to successfully fetch data, I guess. And that wasn't happening. I didn't have this set. So basically there was no request policy. And so I guess by default, no headers are passed to the origin from CloudFront. And so this is just an idea of a default request policy that forwards all viewer headers. And so that seemed to solve my problem. And so that's why that's there. Aliases here. This is for your domain name to be associated with the CloudFront. Viewer certificate. Yeah, so this is in production when we want to associate our ACM certificate with our CloudFront. We just discussed CloudFront cache policy. This is the bucket where our binaries, I guess you could call it, live. and its public access is blocked. So here's the load balancer. So it requires you define which subnets it can live in, I guess. And so I think you have to specify at least 2. So I just specified all the subnets that I had defined previously in the parameters here for this region. You could select specific regions from that map, but I think if you do it this way, then you don't have to worry when you're going cross-region, because some regions have a different number of default subnets. So, and then security groups. So this is the security group for this load balancer, and here is that now. So basically, you have to define what kind of traffic is allowed in this load balancer. So here, I basically, if it's a development environment, I allow traffic from port 80, otherwise port 443, which is the default for HTTPS. And here I have source prefix list ID. So this is limiting requests to only the IP addresses in this prefix list. And this prefix list is the IPs of the CloudFront distributions. And I learned about this through this article here posted on February 7th of 2022. And basically it's just talking about how AWS now has these prefix lists that they manage, which has the IP addresses of the CloudFront distributions worldwide. And so basically this prevents you from accessing this load balancer, without going, you have to go through the CloudFront distribution, which is what we want. So you have to set up a listener for the load balancer to listen for traffic. So, similarly, if it's a development environment, we're going to listen for HTTP requests, otherwise HTTPS. And this default actions defines what you want to do. So we want to forward the traffic to our load balancer target group, which we'll talk about in a bit. And then certificates, if we're running in the production environment, you need to provide the certificate, the ACM certificate ARN here. And that's because for listeners, if you define an HTTPS protocol, you have to provide an ACM certificate for that. And before I move to the load balancer target group, I just want to point out that I followed this article here. Let's see if we can find the author. Well, it's by Storm IT. And basically this article, the title of it, what is the title? Creating a CloudFront distribution for Amazon EC2 and ALB. So this was really my guide to kind of how to set this whole thing up. And I made some tweaks along the way because I'm doing it through CloudFormation. They're doing it through the console. But that's how I got some of this information. So let's talk about the load balancer target group. So the target group is the group that the EC2 instances will be associated with. So here you'll notice it's just port 80 on the HTTP protocol. So by the time your requests hit the load balancer, it's all through SSL. And then once we get in here, my understanding is that that's no longer required. And also, SvelteKit, I don't know how it would handle if you did want to send HTTPS requests from the load balancer to the EC2 instances. You might need to have SvelteKit return some sort of SSL certificates. But my understanding is that even though we're running on port 80 at this point, only the load balancer has access to the EC2 instances. So that traffic only goes between those two entities. There's also something to be said about private VPCs and internet, and the EC2 instances being internet facing. So that's something I don't fully understand. But I think if the EC2 instances are in a private VPC that only the load balancer can access, then there's no way to access the EC2 instances from outside. I'm not sure that's how I have this set up. However, as you'll see later on, I have a security group that only allows the load balancer to access the EC2 instances. And so speaking of VPCs, you have to define the VPC that this target group will be a part of, and that again is defined in the parameters here for this region. So now we'll talk about the auto-scaling group. So here you can set the min size and max size. So, min size can be 1, and then, if you actually have a lot of traffic, you're going to increase this max size so that your system can cover the increased load. So here we're going to define everything through a launch template. That's where we define kind of what type of EC2 instance we want to set up. And actually we can, before we jump there, I just want to cover these next two ones. So the target group ARN, so here's where we define what target group the EC2 instance will be associated with, and that's what we just talked about up here. And you have to define availability zones. And this is a cool function I just learned about. So within the CloudFormation template, you can get all the availability zones for a set region. And so that's what we did here. And so now we'll talk about the launch template. So here I set the instance type to the least expensive instance type. But obviously you can change that to whatever you want. Then we set up an instance profile, which I'll jump to that right now. So let's scroll down here. So the instance profile references instance roles. So basically, we need to provide some permissions to each instance. For example, we need to provide the instance permission to access that S3 bucket that has the files we need. So the profile is kind of an intermediary resource to reference these roles. And here's the role. So for each role, you have to provide an assume role policy, and that basically defines who's allowed to assume this role. So here we're providing the EC2 service the ability to assume this role. And then the policies, here you can define all the policies that you want. And here, so let me just scroll up a bit. We're going to cover what this bash script is, but as you can see, we're doing an S3 sync command, and you need to Google what kind of permissions you need to execute this kind of command. And that's still kind of tricky because there's no resource that I found that clearly states which actions relates to which command. But through some trial and error, I figured out that it's get object and list bucket. So you'll see I have two actions here, well, two sets of statements, I should say. Well, I suppose it's one statement, but two list items within the statement. The first one is the get object, and it applies to all the files. You'll see this asterisk here, all the files within the bucket. This next one is list bucket, and here I'm just defining the bucket itself. I think you can put these two into one item. However, I like to separate them only because the list bucket should refer to just the bucket, not the files in the bucket. And I think just the readability is a bit better setting it up this way. So let's scroll back up back to the launch template. So that was the profile and the role. Image ID, so again, it's the AMI we defined in the parameters. So that'll give us our Amazon Linux 2 operating system. Then you have a security group. So let's scroll back down here. Here we go. So the two definitions I have here, one is, so the load balancer is going to be listening on port 80, or is going to be sending traffic through port 80, I should say. So we want to open up port 80 and open it up to, here you can see we can define the source security group ID. So you just provide the security group of the load balancer, and it'll apply then to that load balancer and not public traffic. And here we've opened up port 22. This is for SSHing into the instance if you need to access that user data log file. And I have it set to all IP addresses. You could, if you didn't want to apply this for production instances, you could have some conditional statement that handles that. So let's scroll back up. So that's the security group. Now the user data parameter here. So this is the bash script, the startup script that will install and run the web server. And then this can apply to things other than the SvelteKit server, obviously. But this is where you define this sort of stuff. So here you'll notice we have the shebang, I guess is what it's called, where it says run this script with bash. And here you'll notice I'm defining the home variable, environment variable, and that's because the user data file or script is executed or run as the root and not as EC2 user. So when you're running some of your commands, or more specifically, I believe it's when you're installing Node here. You want the home variable to be EC2 user because it messes things up otherwise. I can't think of the details of what was happening when I didn't define this, but that's why I have that defined, because it runs as the root, and you just want the home. You want to let the root kind of know where the real home is, which is the home/EC2 user. And then here we just run an update command. And then this I found online. I'm installing NVM, which allows you to install and kind of activate different versions of Node. And so this is kind of all from the documentation there. Here I'm installing Node version 16. And then I'm running the S3 command to get all the files and put it in a folder called website in my home directory. And then this is saying run the build, and you don't have to, you could also do index.js. So in your build folder, there's going to be an index.js file, but you can also just run it like this. And this variable here is saying run it on port 80, otherwise it defaults to port 3000. And I got this from the documentation again. So here you can set some parameters, host, port, origin might be an important one that you need to set, because apparently, so SvelteKit has no way of knowing what the origin is. And you can either set it through this parameter here, or you can forward some certain headers. And if you don't, apparently when you're using form actions, you can get errors like this: cross-site post form submissions are forbidden. So that's just some information on that. And one thing that just came to mind that I want to mention is that this is running on ARM. So the AMI that I provided in the parameters above, it defaults to ARM. And there was something else that I had to set to make sure everything works on ARM correctly, but it's not coming to me right now. But just know that this is running on the ARM CPU architecture, and that's what AWS seems to default to. Well, there's a resource in here that defaults to that, and I can't... Oh, I think the EC2 instance defaults to that. Yeah, it's not coming to me right now, but okay, let's scroll down. We talked about profile role. We talked about the security group. Okay, and then this last bit is, well, this is just a redirect bucket. So for production, I have a condition here. So this only is set up in a production environment. And this just reroutes any www requests to the kind of base domain. Okay, so I think I've covered everything in the template. Let me just take a look here. There's another link here. Aha. So I had also used this link, so basically what was my first thought was I didn't want to use a load balancer. Not that you'd have to use a load balancer eventually if you're running any sort of production environment. But just for my small website, I wanted to test this out on just a single instance, because I think the load balancer is going to end up costing you $16 to $17 a month with it constantly running. And on top of that, I think the smallest EC2 instance costs $3 a month. So you end up, for small projects, $20 a month, could be a lot, especially if it's just a small project. So what I wanted to do was, without a load balancer, you're not going to run, or without using the auto scaling, you're not going to run this command here. You would restart the instance. But this user data file only runs when the node is first created. When the instance is first created and run. But when you restart or even stop and start again, it doesn't run again unless you add this bit of information before your script. And it's specifically this part right here, script user always, which I guess tells the instance to run the user data script, even when it's restarted. However, I was running into issues where the instance, the website was like, some pages would load and other times it wouldn't, and I couldn't tell if maybe that SvelteKit the SvelteKit server wasn't closing properly when I restart the instance, and I didn't go and debug it, so I kind of just gave up on that because, again, you will want the auto-scaling group if you plan to have a production-ready system. And so the ultimate test here is I have a CloudFront development distribution running. And so this is it running. You can see if I click the links, it properly navigates and the URL is updated. If I type in some page that doesn't exist, I get the proper 404 message. If I manually type in /2 here, it loads it properly. So you've got your routing set up and you've got your page set up. Now before I end this, I just want to make sure I've covered everything. I think I have. So yeah, I will have this template on my GitHub if you want to take a look. And again, this can be applied to, things other than SvelteKit. You can run your own custom servers and set up. You have an auto-scaling distribution here behind CloudFront. So thank you for watching and have a good day.